Good morning, friends. Today we are going to discuss about the Young's double slit experiment. Already we discussed about the coherent and incoherent sources, and we obtained the intensity of the light due to the constructive interference and destructive interference, and also due to the coherent and incoherent sources. Right? Today we are going to discuss about what is the path difference at any point on the screen in Young's double slit experiment, in which the phenomena of the diffraction take place, phenomena of interference take place. Clear this? So for that purpose, here we consider the two slits S1 and S2 behave as coherent sources. So how we obtain the coherent sources? First, the definition of the coherent sources is that if the two sources oscillate with the same phase, or the phase difference of the oscillation of the two sources remain constant with time, so such sources are known as the coherent sources. For that purpose, here we consider the first slit S. First slit is S. That is the source of light. Now, so due to this slit or the source S, here the spherical waves are generated. These spherical waves are incident on a double slit S1 and S2. S1 and S2. That is the S1 and S2. The separation between the S1 and S2 is small d. Actually, here the S1 and S2 are the pinhole. So, what are the waves are generated from the S crest, torque. So here the S1 and S2 are at equal distance from S. S1 and S2 are at equal distance from S. Therefore, the same wavefront is incident on S1 and S2. So according to the Huygens principle, the S1 and S2 act as secondary source and produce the secondary spherical wave. So this S1 and S2 act as a separate the source, and which produce the spherical secondary waves. This wave propagates in the medium and incident at point P on the screen. Now the screen is this, which is a distance d, capital D from the slit S1 and S2. This distance is d, which is a perpendicular bisector. D distance from S1 and S2. The scale is G dash. The waves from S1 and S2 superpose at point P. The P is at x distance from O. X distance from O. Now, there is a S1. S will the perpendicular from S1 on screen. So, that is our aim. This distance is d by 2. This distance is d by 2. Because the S1, S2 is d. And S is the perpendicular from S2 on screen. So this distance is also d by 2. Now, what is the distance of P from A? This distance is our total x minus d by 2. So x minus d by 2 distance. That is from O. And the similar way we do the perpendicular on screen, GG dash from S2, that is our N. Distance of N from the P, that is the x plus d by 2. X plus d by 2. Because that is up to O to P x plus d by 2. So that is the diagram of our Young's double slit experiment. Here the slit S1 and S2 act as two slits. Therefore, this experiment is known as Young's double slit experiment. Now the 1A from S2 is also incident at P, and these two waves are superposed, and as a result, the interference is formed at point P. So that is our diagram. Now we describe it as shown in figure. As shown in figure. Suppose distance between S1 and S2 is small b, which is in order of millimeter. Next, the screen is at distance capital D from perpendicular bisector of S1 and S2. S1 and S2. D is in order of meter. D is in order of meter. Now, the waves generate from source S. Out of these waves, the one wavefront incident on S1 and S2 at the same time. The wavefront out of wavefronts produced from S incident on slits S1 and S2 at the same time. So S1 and S2 act as a coherent sources. Act as a coherent sources. So here, the numbers of the wavefronts are generated by S. Out of this number of the wavefront, any one wavefront is incident on S1 and S2 at the same time. Therefore, the phase difference of the S1 and S2 are same. Therefore, the S1 and S2 act as a coherent sources. Now, due to superposition of waves, interference is obtained. Interference is obtained at P. So here, these waves are propagated in the medium, and at point P, they are superposed. Therefore, the interference is obtained. The maximum or minimum intensity of point P depends on the path difference of S1 and S2 at P. The maximum or minimum intensity of light at P depends on path difference at P of S1 and S2. S1 and S2. Now, we assume that suppose the OP is X. Suppose OP is equal to X and S1M is perpendicular to the S1M is perpendicular to the GG dash, that means perpendicular to the screen, and S1N, this S2N, is also perpendicular to the GG dash. It is also perpendicular to the GG dash. Now, for this S1M is equal to D and PM is equal to X minus D by 2. X minus D by 2. And this S2N is equal to D and this PN is equal to X plus D by 2. X plus D by 2. We are interested to obtain the equation of the path difference at point P. Therefore, path difference is S2P minus S1P required. Clear? For that purpose, here, triangle, we consider this triangle PMS1. PMS1. Now, S1P square is equal to S1M square plus PM square. S1M is our D square plus PM square X minus D by 2 whole square. And from triangle S2NP or the PNS2 S2P square is equal to S2N square plus PN square is equal to D square plus X plus D by 2 whole square. So thus we obtain the equation of the S1P square and S2P square. Now we take the difference of this, therefore S2P square minus S1P square. Therefore, D square plus X plus D by 2 whole square minus this square minus X minus D by 2 whole square. This square cancel. Thus we obtain X plus D by 2 whole square minus X minus D by 2 whole square. Now we simplify A plus B whole square. So A square plus 2AB plus B square. So according to that, X square plus XD plus D square by 4. Here second term open with the negative sign. Therefore X square minus and negative positive. So XD and minus D square by 4. That is cancelled. Therefore, that is the 2XD. Therefore, S2P square minus S1P square is equal to 2XD. That is the equation. After that, we have to simplify x square minus y square. So x plus y, x minus y is equal to 2xd. Okay, up to this we again revise. First, what is the description of figure? What is shown in the figure? The distance between the two slits S1 and S2 is d. Right? That is in order of millimeter. That means the very close S1 and S2. Now the screen GG dash is at distance d from slit S1 and S2 and also at perpendicular bisector. Screen GG dash is at distance d from perpendicular bisector of S1 and S2. Now capital D is in order of meter, very large compared to the small. Now S is the source, here the numbers of the wavefronts are generated, therefore the one wavefront out of wavefronts produced from S incident on S1 and S2 at the same time. Therefore, the S1 and S2 act as their coherent sources. Now, due to the superposition of the wave, here the interference is obtained at point P. Now, the intensity at point P, either maximum or minimum, depends on, or the maximum and minimum intensity of the light at point P depends on path difference of S1 and S2. It means we have to obtain the equation of the path difference at point P. For that purpose, here, do S1M perpendicular to the GG dash and S2N which is perpendicular to the square GG dash. S1N is equal to D and PM is equal to X minus D by 2. The similar way S2N is D and PN X plus D by 2. Now, from triangle PMS1, first triangle, the S1P square is equal to S1M square plus PM square. We substitute the value D square plus X minus D by 2 whole square. The similar way second triangle P and S2. So S2P square is equal to S2N square plus Pn square. Therefore D square plus X plus D by 2 whole square. Now taking the subtraction of these two equations, so S2P square minus S1P square is equal to D square plus X plus D by 2 whole square minus this. So minus D square and this also minus into bracket X minus D by 2 whole square. We simplify, last we obtain S2P square minus S1P square is equal to 2X. Okay, now last we obtain this equation S2P square minus S1P square is equal to 2XD. Now we simplify like this equation x square minus y square is equal to x plus y x minus y like this. Therefore S2P minus S1P into bracket S2P plus S1P is equal to 2XD. But the distance is x and small d are very small compared to very small compared to capital D. Therefore, S1P we consider D as S2P. That means the value of S1P and S2P both are same and that is the capital D. Why? There is the very small x and D. Now D is in order of millimeter. Now capital D is in order of meter. Therefore, capital D is 1000 times more than the small d. Okay. Now the x is also in millimeter or centimeter. So that is also very small compared to the d. Therefore, actually the distance of the S1P and S2P is very large. Therefore, we consider as the distance of the screen. Therefore, S1P is equal to S2P is d. Therefore, path difference at P is S2P minus S1P is our path difference. Into second bracket D plus D is equal to 2XD. Therefore, S2P minus S1P is equal to 2x d upon 2d. Therefore, x d upon. So that is the thus path difference is equal to x d upon d. That is our aim, to obtain the equation of the path difference at point P in Young's double slit experiment in terms of small x, small d and capital D. Okay. Next, we are going to discuss about that which type of the interference take place on P, or what is the intensity of the light at point P. If the constructive interference is take place, so here the light at point P is maximum according to this equation, and if the destructive interference take place at point P on the screen, so intensity of the light is minimum. For that purpose, first we assume that suppose at point P the constructive interference take place. For that purpose, if at P constructive interference take place, interference is formed. Therefore, path difference for constructive interference is equal to n lambda. Is equal to n lambda. Therefore, from equation 2, n lambda is equal to x n d upon d. Here, xn is equal to distance of P from O. So from this equation, xn is equal to n lambda d upon P. So that is the equation of distance of nth order that is obtained at xn distance from the center of a scale. So xn is equal to n lambda d upon d. Thus, at xn distance from O, nth order constructive interference is formed, and that point P and intensity at that point P at point P is maximum. So from the path difference we can obtain the position or the point at which the nth order constructive interference take place, or nth order band fringes is obtained in interference. Now, second case is that if at P destructive interference is formed, destructive interference is formed. Therefore, the path difference is for destructive interference is n plus 1 by 2 into lambda, or in other words, 2n plus 1 into lambda by 2. From equation 2, n plus 1 by 2 lambda is equal to our path difference xd upon capital D. Here, xi is equal to distance of P from O. Because that is the nth order, therefore we take this distance as xn. Therefore, xn is equal to n plus 1 by 2 lambda d upon d, or 2n plus 1 into lambda d upon 2d. That is the distance from point O at which the nth order destructive interference takes place, and the intensity at point P is minimum or zero. Thus, and extend distance from O, nth order destructive interference is formed and intensity at point P is minimum or zero. Minimum or zero. So here the importance to obtain the equation of the path reference is that on the base of the path reference we can judge about that the intensity at point P at which the two waves are superposed. So here last one equation is S2P square minus S1P square is equal to 2xd in Young's double slit experiment. Here we simplify this left hand side by x plus y, x minus y. Therefore S2P minus S1P, second bracket S2P plus S1P is equal to 2xd. But the distances x and small d are very small compared to the capital D. Therefore we consider the S1P is equal to S2P is equal to capital D. Therefore the path reference at point P is S2P minus S1P. Here we substitute the D, therefore D plus D is equal to 2xd. Therefore S2P minus S1P is equal to 2xd upon 2d. 2 cancel, xd upon d. So there is a required equation of the path difference in Young's double slit experiment at point P on the screen. On the base of this, suppose that sometime the question is also extended for 3 or 4 marks, and obtain the distance from the midpoint of a screen at which the nth order constructive and nth order destructive interference format. If at point P, here we take, suppose at point P the constructive interference take place. So path reference for constructive interference, already we know that there is a n lambda. So compare this n lambda with xd upon d. Therefore n lambda is equal to xn d upon d. xn is the distance of nth order constructive interference take place. Therefore xn is equal to n lambda d upon d. So there is a equation number 3. Thus xn distance from O, n order constructive interference is formed and intensity at point P is maximum. Now similarly, let's assume that if at point P the destructive interference is formed, therefore path difference for the destructive interference is n plus 1 by 2 into lambda or 2n plus 1 into lambda by 2. We compare this path difference for destructive interference with our equation of the path difference xd by d. Therefore n plus 1 by 2 lambda is equal to xn d upon d. Therefore xn is equal to n plus 1 by 2 capital lambda into small d upon, or in other words, as we use this equation, so 2n plus 1 lambda d upon 2. Thus at xn distance from O, the nth order destructive interference is formed and intensity at point P is minimum or 0. Here we take here the dash, for that purpose action dash. Clear this? Okay. So that is the Young's double slit experiment and equation of the path difference in order of small x, small d and capital D.